All right. Yeah, thank you, Juan, for that introduction. Yeah, my name is Rob Graham. I'm with the Los Angeles County Enterprise GIS team. And following up on the great presentation by EagleView, I think this is an application of how we're using imagery to solve or contribute to solving a public health problem. So real quick, this is kind of what we'll talk about here. I'm just going to talk through the project a little bit, the context, how we worked with the imagery, how we adapted the software, and kind of some challenges we had with running it, and then kind of where we are now. And so the first question is, why do we care about cooling towers? So cooling towers are, I didn't actually really know what they are. They kind of look like air conditioners, but they're these cooling systems on generally like big industrial buildings, and the mist from them can actually contain Legionella, which can cause Legionnaires disease, which is a type of pneumonia, and it can kind of dissipate into the surrounding areas. So we had a goal of creating an inventory of all the cooling towers in the county, working with public health to do this. They provided a lot of leadership. To create an inventory, and then we would be able to, monitor them, ideally, make sure that they're maintained and in good working condition. And then if there's outbreaks, we can investigate them or respond to them. Yeah, so we've had a lot of leadership from Department of Public Health here at LA County on this. And then we've also been building off of work that was started by the CDC and UC Berkeley to kind of develop the original TowerScout, and then the state of Utah that has been working on kind of how we can apply it to custom imagery. So our first step with this was to prepare the image data, because so LARIAC comes in as a mosaic. So we have, so it's one giant image. And so in terms of like defining our workflow and how we were going to process it, TowerScout takes images in tiles. And so the first thing we did was we broke this mosaic into georeference tiles. We saved that into a database, which allowed us to track as it was running. So you can see like it would go from process status null to in process to complete. And then we'd kind of get like these results. So like how many cooling towers did it find? Like found 14 cooling towers in 4 minutes. Depending on where it was running, and I'll get to that in a second, it would go faster or slower. And yeah, and so that was really about doing our workflow. And then taking that, we wanted to use that to adapt the TowerScout software. So you can see these two like GitHub repositories is kind of where our starting point was. And so basically it's break these bigger tiles into smaller tiles and then run them through the model and then capture the results and go from there. And so in a little bit more detail, a big step that actually took a little while was like getting together the Python environment that we were going to use. So there's PyTorch, YOLO v5, which is a machine learning model, and then ArcGIS tools, and getting those to all kind of play well together was a little bit of a challenge, but then once it was set up, it was good. And then we just basically, the script would just pull random bigger tiles for processing. So ArcGIS has like a split raster function. So the first step in the program would be to take that big tile, break it into the 640 by 640 pixels that are actually needed for the model to work. And then those smaller tiles would go through the TowerScout pre-trained model. And then, an interesting thing was what we were getting back was pixel coordinates, but we actually needed geographic coordinates. And so we discovered that you can use actually the Esri world files. In this case, since it was a JPG tile, it became a JGW world file. And that's what this is down here. This is kind of interesting. So this is what it looks like. It's just like 6 lines of numbers. but you can feed that into a formula and get actual geographic coordinates based on the pixel coordinates, which is, I think, pretty cool. So those results, when they would come in, we would save them to a feature class into our database. And then the way it was set up, we were also saving it to ArcGIS Online just to kind of track the results. And so running the program was a lot, as you can imagine. So that image that I showed at the beginning, so there's about 13,000 larger tiles in that. And it took, on average about 10 minutes to run each one, which, equates to like 90 days of processing time. And, this was kind of a project that we were trying to do quickly. So we wanted to give it maybe 2 weeks to finish. I think we did actually get through them all in maybe 5 weeks. So that was good. But it was super resource intensive, and wherever you were running it, it would basically always take like 100% of your your computing power. So when we were just kind of trying it out, I started it on my laptop. I started it on my desktop in the office, so it could kind of run in the background there. We ended up putting it onto our EGIS image server, so it had just like a server place to run also. And then when that was still not fast enough, still not moving along fast enough, we actually created like a new dedicated server for it. And so all that kind of like those 4 concurrent runnings over about a month is what it took to get through the entire county. And so then we started getting results, and our initial results, well, first it was fun because we saw detections coming in. So it was like, oh, it's found like 6 cooling towers. It's found like another 20 cooling towers. And then it was kind of like, oh, we're like 10% through the tiles and there's, 80,000 cooling towers, like something's happening here. So we ended up, over 200,000 detections. So each of these points are a potential cooling tower that was identified by TowerScout. And then obviously, like a lot of them were false positives we were finding. So air conditioners are the biggest culprit, which makes sense. They look a lot like cooling towers. But sometimes it would pick up cars, it would pick up containers, a shadow that was hitting something the right way. Plant holders, which I'm not sure, it seems like that's something that this might be. But yes, so we had quite a bit come in. And so our first kind of step, because this 200,000 point data set wasn't really manageable and clearly had too much data in it. So we had kind of 3 main criteria that we were able to start screening it out. Like one, it had to be in Los Angeles County, which most of the imagery in LARIAC is in LA County, but it does kind of like bleed over the borders. So we just kind of cut everything else out that was on the outside. We have building outlines. And so we did an analysis to make sure all of them were in 30 feet of a building. So to like stay in the data set, it needed to be within 30 feet of that building. And then and we could also use the parcel data to say it couldn't be a residential property that was under 5 stories or under 5 units, excuse me. And so that's what that's kind of what we used for our screening to kind of get our starting point data set. And with that put us down to 110,000 point detections. Those were in 28,000 parcels and then 32,000 buildings that are spread across the county. And this is just SQL code. So I think one important thing is like having this data in the database allowed us to do this kind of analysis just like in simple SQL queries to establish these criteria. And so from there, we wanted to look at how we were going to do our QA because that's still a large number. I think what we're expecting was, maybe 30,000. I think 10 to 30,000 was the range that we were kind of expecting of number of cooling towers to find. So we're still, way above that number, obviously. But starting from our screen data set, we started to look at, how can we have subject matters review each of these, look at each one. I've actually learned a lot about like how you can tell a cooling tower versus an air conditioner. And so we created this tool to allow public health, to allow other partners that we can get to help us start reviewing these and go through. And so this is based off of, we took the database layer and created an editable REST service for it. And then we added in these domains for the review tracking. So you can see, like, for example, this point is selected, it's potential cooling tower. If it is not a cooling tower, it's probably one of these things, or at least it's unknown, definitely. And so that kind of can manage like what we're finding. And yeah, so that can manage like what we're finding, and as points get reviewed and confirmed if they're cooling towers or not. The other like interesting part of this is we wanted to, we had the 30,000 buildings or so. We wanted to be able to say like all the points on this building are a cooling tower, or all these points are not a cooling tower, for example. So we were able to build in using attribute rules, actually, able to build in, if you kind of set a building as this is a confirmed building with cooling towers, that it will just pick up all of them that are on the building. Other things that we can look at when we're doing the QA is there's a model confidence that comes through with the when the program runs. And so that's like 0 to 1. So if it's close to 1, if it's like 0.89, then the model is like super confident. If it's something like this, 0.28, it's like not very confident that that's an actual cooling tower. So we can use that to guide us a little bit. And then also we were looking at distance to the nearest other point. So if there's a cluster of points, then they are most likely a lot of air conditioners strung together. Like if there's too many points that are kind of in the same area that are really close to each other. And I can show a demo of that if I think I have a couple of minutes actually, so maybe I will just show that since it's here. So for example, so we have, this is just like an editing tool. We have our cooling towers, we have our buildings, and you see like the person going through can actually look at these and mark if they're reviewed, mark if they're confirmed, mark what it is. We can sort these by, low to high confidence or vice versa. And then interestingly, so we can do the same thing with the buildings. Give it 1 second to load. And of course it won't, but you can see the the editing form here. And so basically, whoever is reviewing this, who actually knows about being able to look at cooling towers or being able to look at an image and tell if it's a cooling tower or not, can come through and they can say, reviewed, yes or no, confirmed, yes or no, it needs more info, one of these notes like I was talking about, and then extra notes if they want to add them there. Cool. And then this is interesting too, because with the buildings, we can actually, this field, if we mark it as yes, then it'll apply to all the buildings that are on, or all the points that are on that building. So I think that will be useful. And then just some takeaways and what we've learned from this. It is very resource intensive to do kind of this image processing. And so I think if we did it again, we just we didn't know how long it was going to take. So we just started it in a few different places and kind of let it run. But I think if we were doing this again, we would look into, we could do like containers, we could do something on AWS where we're kind of scaling up and just using like huge amounts of processing power. QA is kind of a huge step. And I think when we were like scoping it out, we had this idea that we'll get all these, we'll just run all of our imagery through this model, and then we'll get all the detections, and then we'll basically have an inventory. But I think what we found out is we were getting a lot of false positives. And I think, as I've done more research, I think that's pretty common in applying some of these machine learning tools. And so really that's what we're going through right now, is how do we QA that down and get like an actual accurate count that we can take action on to develop the inventory. I'll just mention, keeping all of this in a database was way more efficient than having an ArcGIS Online, for example, or even working with like ArcPro to do some of the more intensive joins, like the points to parcels and et cetera. Like it just goes way faster if you do it in SQL. And then for next steps, one thing we're looking at is, now we have this big data set of points that are not cooling towers, and ones that are, and how can we incorporate that back into training the model? So this project was really taking a pre-trained model and running our imagery through it, but how can we actually train the model to make it better? And then we're also talking about, like, should there be different models for different places? Like based on the land cover of LA, it might have a different model that it's looking at versus New York or somewhere else where it's been done. Similarly, just contributing like what we've learned and our code back into the community so that people can use it. And then just diving into other ways that we can use the LARIAC imagery to do either using, I know Esri has lots of kind of pre-trained models that are available for detecting various types of things, and or we could create our own, depending on what the next project will be. And that is all. Thank you so much, everyone, for joining.